Alright, so now let's explain the difference between homolytic cleavage and heterolytic cleavage. Okay, let's have a look at the homolytic cleavage first. Okay, if you look at this table, alright, for the homolytic cleavage, it occurs in a non-polar bond. Okay, where the atoms have similar electronegativity. Okay, so for example, if you have Cl2, okay, you can see here, okay, we have two chlorine atoms, so it got same electronegativity, similar electronegativity. All right, so it is a non-polar bond. So the single bond will break symmetrically. Okay, since the atoms got same electronegativity, so the single bond will break symmetrically. In one single bond, we have two electrons. So each chlorine atom will get one unpaired electron. So we are going to show the movement of the electron by using a curved arrow. Alright, so this one electron will go to this chlorine and the other one electron will go to this chlorine. Right, so we are going to use a single headed arrow, okay, because we only move one electron. So after this bond is break, right, so each chlorine atom will get one unpaired electron. Okay, so this unpaired electron, okay, represent the free radical. Homolytic cleavage, it occurs in a polar bond where the two atoms got different electronegativities. For example, if you have HCl, right, hydrogen is partially positive and chlorine is partially negative. Chlorine atom is more electronegative compared to the hydrogen atoms. Alright, so since these two atoms got different electronegativity, it will break unsymmetrically where the more electronegative atom will get the both electron. So now I'm going to use the curved arrow, okay, to show the movement of electron. Since these two electrons will go to the chlorine atoms, so we are going to use a double-headed arrow, right? And then after the bond is break, okay, we will get a H plus and a Cl minus. So these two ions is a cation and an ion. Have a look at the next question. Okay, so we are going to use a curved arrows to show the movement of electron in each reaction and then identify the type of cleavage. For the first reaction, okay, if you look at this molecule, okay, we have a Br2 molecules, okay, so same atoms, so we have same electronegativity, similar electronegativity, and then it forms a free radical. So if you look at this reaction, this is a homolytic cleavage. So this single bond here will break symmetrically. Okay, we have two electrons here. One will goes to this Br and the other one will goes to this Br. Okay, so this one is a homolytic cleavage. For the second reaction, if you look at the product form, okay, we have a positive and negatively charged ion. Okay, so these two is a cation and an ion. So the reaction is occurs between this carbon and this Br. Okay, so this is a heterolytic cleavage because carbon is partially positive, right? Carbon is partially positive and Br is partially negative. So there are difference in electronegativity between carbon and Br. So this single bond will break unsymmetrically where bromine will get both electron. So we are going to use a double-headed arrow. For the third reaction, okay, we have a free radical here. So free radical is involved in this reaction. So it is a homolytic cleavage. So the reactions occurs between this carbon and also this hydrogen. So for the homolytic cleavage, we know that each atom will get one unpaired electron. So we give this hydrogen one electron and this carbon one electron. for the product here, we have the HCl. Okay, so there is no H radical formed here. Okay, but the hydrogen here, we can see that it make a bond with the chlorine atoms. So since the Cl here got one unpaired electron and the hydrogen here got another one unpaired electron, these two will combine and form HCl. So the first reaction is homolytic cleavage, the second reaction is heterolytic cleavage, and the third reaction is homolytic